Hello everyone. Today we are going to discuss the VTU problem based on current and voltage divider rule. Part 2. The problem is a 10 ohm resistor is connected in series with parallel combination of 15 ohms and 20 ohm resistor. The circuit is applied with V volt. Power taken by the circuit is 150 watts. Find the total power through the circuit and power consumed in all resistor. So according to this question, we have drawn the circuit diagram. 15 ohms and 20 ohms are connected in parallel and 10 ohms is connected in series. Now for the finding the total resistance, here they given all the resistor value, but we don't know the total resistance or equivalent resistance. So already we know the formula. Here 15 ohms and 20 ohms are connected in parallel. So if you apply the formula, R1 R2 divided by R1 plus R2, will get R is equal to 8.57. That is, only this part of this value is 8.57. Now here 10 ohm is connected. 10 ohm is connected with series with this value, that is 8.57. So 10 plus 8.57 will get R total is 18.57 ohms. Now P is equal to V square by R. Here the P value is known and then R value is known. So V value is unknown. So if you substitute that formula, that is, already we know that P is equal to VI, P is equal to I square R, P is equal to V square by R. So if you substitute the value, we'll get V square is equal to 2785.5. So from this if you find the value of V is equal to 52.77 volt. So now total current, we don't know the total current. So the total current formula I is equal to V by R according to Ohm's law. I is equal to V by R. So if you substitute that value here, so we'll get V total by R total, we'll get I total is 2.84 amps. Next we have to find the current in all branches. So we are supposed to find I1 and I2. I1 formula is I1 into R2 divided by R1 plus R2. Similarly I2 formula is given. If you substitute the formula, we'll get 1.62 amps in I1 and 1.21 for I2. Now ultimately we have to find the power in all resistors. So P, power in all resistors, means P is equal to I square R, because according to the circuit diagram, now we found the current in all branches and resistance also it's given. So P is equal to I square R means the power across 10 ohm resistor will get 10 ohm means the total current is 2.8, so 2.84 square into resistor value is 10. So if you substitute, we'll get some value, that is 80.656 watt. Similarly, power across P 15 ohms and 20 ohms we found. So the total power we had to add all the values. Power across 10 ohms, power across 15 ohms, power across 20 ohms. So we'll get 150 watt. As whatever given the question, we are getting the same value. It is near to 149 point something it will be there. So it is near to 150 watts. So next problem. So in this problem, 8 ohm resistor is in series with parallel combination of two resistors, 12 ohms and 6 ohms. If the current is 6 ohm resistor is 5 amps, determine the total power dissipated in the circuit. They asked in July 2016 for 6 marks. So here the mark split up also is given, weightage of the marks. So according to this question, we have drawn the diagram. 12 ohms and 6 ohms are connected in parallel and 8 ohms are connected in series, and then in 6 ohm we are getting the 5 amps current. So we have to determine the total power dissipated in the circuit, that is P total, and then here the considering the current in the 12 ohm branch as I1 and 6 ohm branches I2, just I am considering. So this is I1, this is I1 and this is I2. So I2 is 5 amps. So the voltage in 6 ohm resistor, is V is equal to IR, that is I2 into I2. Here I am considering this is R1, this I am considering is a R2. So here as for the formula, this is I2 into R2, So if you substitute the value of 5, I2 is 5 and then R2 is 6. So the total here the voltage across this branch is 30 volt. So here 12 ohms and 6 ohms are connected in parallel. So once it's connected in parallel, whatever the voltage is in this branch, the same voltage will remain constant, because already we discussed the concept in a parallel circuit the voltage will remain constant. So 12 and 6 ohms are connected in parallel. The same voltage, 30 voltage, will be in the 12 ohm resistor also. So V is equal to IR. So according to that formula, we can easily find I is equal to V by R. That is, I1 is equal to V1 into V1 by R1. So V1 already we know that 30, and then R1 is 12, so we'll get 2.5 amps. So I1 is equal to 2.5 amps in branch 12 ohms. In branch 12 ohms. So next total current is I1 plus I2, because I1 is entering, I is entering, I1 and I2 are the outgoing, so I is equal to I1 plus I2. So I is equal to, if you add this, you'll get 7.5 amps. So the total resistance means these two are in parallel, 12 ohms and 6 ohms are in parallel. So 12 and 6, if you substitute the formula R1 R2 divided by R1 plus R2, and then 8 is connected in series. So if you add this, you'll get 12 ohms. The total resistance is 12 ohm. So the power dissipated, power P is equal to I square R. I value is known, 7.5. So 7.5 square into 12. Therefore P is equal to 675 watt. And one more method is there. Here we found the total resistance, and then here we know all the branch current and branch resistance. So instead of that, you can put that I square R for all branches, for this branch, for this branch, for this branch. First, for here we know that the total current is 7.5, so 7.5 square into 8 plus, and then here the current is 2.5, that is I1 is 2.5 square into resistor value is 12, and then I2 square, that is 5 square into resistor value is 6. So if you substitute and add this, you will get 675 watts. I hope you enjoy this video. Thank you.